Good morning and welcome to Hazardous Substance Classifications, the first in our series of online webinars. My name is Chrissy Cowie and I am the Consultant Coordinator at Chemsaf. Chemsaf is a New Zealand-owned company which was started in 1992. We have a team of 19 based at our offices in Christchurch and Wellington. Our consultants provide hazardous substance and occupational hygiene services to businesses, and all of our consultants are science graduates. We're here to help you keep your team members safe and healthy at work and to navigate the New Zealand health and safety regulations. There's a Q&A tab at the bottom of the screen where you can post questions. If you like one of the questions already posted by someone else, you can click on the upvote button, and the more voting it gets, the higher up the list it goes, and the more likely it is to be answered during the session. Please don't use the chat function for any questions, as we may miss these. But any unanswered questions will be added to the follow-up email that you guys will receive. Dwayne will be presenting our webinar today. Both him and I have been with Chemsaf since 2013, and during that time he's become the main presenter of the Certified Handler and Chemical Awareness courses. Dwayne specialises in customising training to meet clients' sites and their team's needs. He is approved by WorkSafe New Zealand as a compliance certifier for certified handlers. With a Bachelor in Science from Canterbury University, majoring in chemistry, coupled with his musician background. Dwayne's training sessions are factual, practical, and delivered in a relaxed manner. He is always approachable and happy to take the technical and explain it in plain English. I will now hand over to Dwayne.
Oh, that was really great. Thanks, Chrissy. Fantastic introduction. Hi, folks. Yes, I'm Dwayne Bennett. Good to see you all. It's our very first series of webinars that we'll be doing. The first one being, of course, a HSNO classification presentation. Okay, so before we get started, what we'll do a very brief run through the definition of what a hazardous substance actually is, as defined by the minimum degree of hazard notice. So if you just bear with me, I'll just pull up the slideshow and we shall get started. Okay. Right. Okay. Shall we get started then? Okay, so hazardous substances and HSNO classifications. So I guess to get started, as I mentioned before, we'll go through what hazardous substances actually are, what they actually mean, how they are described as per minimum degree of hazard notice through HSNO and the EPA. So let's have a wee look at this. Okay, the first slide we have here are our hazardous substances. So as you can see there, the hazardous substances include things that are explosive, flammable, oxidizing, toxic, corrosive, and ecotoxic. Okay, and on the slide we can see that it's being depicted by the red ring there. So everything that is supposedly those hazardous substances are represented by that particular red ring. Now, after that, we have things that are known as dangerous goods. Now, this is dangerous goods for transport. So as you can see there, a majority of dangerous goods do fall into that category of hazardous substances. However, some dangerous goods aren't considered to be hazardous substances because they do not fall into that explanation or that minimum degree of hazard notice that we outlined earlier, that explosive, flammable, oxidizing, toxic, corrosive, or ecotoxic definitions. And then finally, we have a ring that represents substances that are hazardous to our health. So again, as you can see there, that all of those hazardous substances fall into this category. However, there are some things that do not fall into this particular category of hazardous substances as by definition. So if you'd like to ask any questions on what they could be, feel free to leave a wee message there in the Q&A and we can answer them later on and via email. Okay, next slide. Right, so we'll get straight into it there. So we'll talk about our hazardous classifications, okay? So you're able to find this information on what the classifications are in the EPA notices, the EPA notice which is the Hazardous Substance Classification Notice 2017. And what these HSNO classifications are is basically like a code. It's a code that we're going to decipher this morning. And it's a code of numbers and letters that indicate hazard, that tell us what those hazards are and what the degree of those hazards are. So the very first number represents the class of that hazardous substance. And then the second and subsequent numbers represent the subclasses of that hazardous substance. And then finally, the letter at the end of that code gives you a measure of degree of hazard. Now, the beauty of the HSNO classification system is that it outlines all hazards of that particular hazardous substance as per minimum degree of hazard notice. Okay, so that's the difference between our HSNO classifications and what you might see on, say, a DG placard or the DG for transportation, where they'll outline the main hazard but won't talk about all of the hazards that are associated, or they'll outline the main hazard and the subsidiary hazard potentially. Okay, so with our HSNO classifications, yes, they are HSNO classes. However, they do correlate with a thing known as the GHS classification system, the globally harmonized classification system. So luckily for us, yes, our New Zealand HSNO classifications do correlate with that. It's quite important to note that we are the only country in the world that uses this HSNO classification system. We do have documents that allow us to correlate the differences between HSNO and GHS. I think with the GHS system, we'll probably cover information about that maybe on another webinar later on in the year. Okay, we'll move right on. Okay, so this is our wee sort of like a chart that we have here at Chemsaf that we've made that outlines all of the classes, the subclasses, the descriptions, and degrees of hazard. There's also some wonderful colourful pictograms on this particular chart, and these are the substances and these are the hazard classes that we'll be going through this morning. Okay, so our hazard classes. They include, okay, so class 1 represents our explosives category. So if you remember back to the third slide, I think it was, where we talked about what substances were covered by the minimum degree of hazard notice, these hazard classes represent those particular substances. So we have class 1, which is explosives. Class 2, our flammable gases. Class 3, flammable liquids. Class 4, flammable solids. Class 5, oxidizers. Class 6, human toxic. Class 8 and 9, corrosive and ecotoxic substances. Okay, so what you might notice is there is a number missing. Often people will say that. They'll say, well, what happened to class 7? Class 7 indeed represents radioactive materials. However, radioactive materials are not covered in this talk and are not managed under HSNO. They have their own piece of legislation that covers the controls and covers the safe handling of radioactive material. So it's not covered this morning. So if we move on, what we have there is another thing to note is class 1 explosives. There are quite a few subcategories there. I think it goes class 1, then it goes 1.1 all the way up to 1.6. And they have different types of degrees of hazard. Just to be aware, yeah, class 1 explosives, they do have quite a variety of different hazards associated with them. Okay, let's get into it. Next thing we'll talk about here are our class 2 substances. Well, class 2.1.1 flammable gases and 2.1.2 flammable aerosols. Okay, so there are some common examples of our 2.1.1 gases, which include LPG. As you can see, they're compressed and flammable. And our aerosols, of course, they can be anything from spray paints or CRC that you'll be using in the workplace to something as common as deodorant, hairspray, fly spray, things like that. So these are our class 2.1 flammable gases. Okay, so you may find you'll see things that are DG classifications, the 2.2s, they include the non-toxic gases. So things like your compressed nitrogen gas and things like that. And also you'll have 2.3 that are toxic gases. So just do be aware of them. These are hazardous these are substances that do not fall under the category of flammable gases. Okay, so the next HSNO classification that we will look at, the next class that is class 3 flammable liquids. So as you can see there, it is divided into 2 subclasses, 3.1 being our flammable liquids, And then our 3.2, our liquid desensitized explosives. So flammable liquids are quite interesting. We're all quite familiar with them. Basically anything from petrol to ethanol to acetone, any kind of paints, solvents, any of those kind of things, diesel even to a lesser extent. The 3.2, liquid desensitized explosives. These are things that are not commonly used in the workplace. There's an example of some nitroglycerine solutions, and can be used in all sorts of properties, however, not as common. So just a quick heads up there, just a quick explanation of what a flammable liquid is. It is actually a liquid that gives off the flammable vapor and is measured by a flash point and boiling point. So that flash point is the temperature at which the solvent vapor will burn given a source of ignition. Okay, and what we will cover in the degree of hazard section is the differences between the differences in flammability, the differences between flammable and combustible. So what you'll find is that will be quite an interesting section. So we'll move on to class 4, flammable solids. Okay, so those of you that are involved in these particular substances, what you'll find is you'll have class 4.1.1 are the ones that are readily combustible. So materials that are easy to ignite and readily combustible, and include substances that cause fire through friction. They are represented by this particular pictogram here. There are a variety of different examples that we have, as you can see there on the slide. Things like aluminium powder, magnesium ribbon, red phosphorus, and sulfur. And then the 4.1.2, so this subclass is still represented by that particular pictogram, and these are materials that do not need external agents such as oxygen to react or combust. They can become unstable due to heat, impurities, friction, or impact. A good example of that is the old lithium azide. Next slide. Okay, so still with the 4.1s, the 4.1.3 are the desensitized materials, okay? So these are materials that would be a class 1 explosive, except they have been desensitized by some agents such as water or alcohol. Okay, so those are the examples there. So if we move on to the next type of pictogram that we have, which are the 4.2s, these are quite interesting. These are things that are spontaneously combustible. So substances that are liable to spontaneously combust are the pyrophoric, that combusts in the air, and self-heating substances. So we have magnesium powder, carbon, white phosphorus, or even things such as soybean meal, represented by that particular pictogram on the right hand side there, the red and white, the one with the red at the bottom and the white at the top with the 4 and the black flame. And then finally, when we're talking about class 4 solid flammable solids, we'll look at our 4.3s, which are the substances that are dangerous when wet. So these are substances that will release a flammable gas when they come into contact with any kind of water. Those of you may remember back to the old science days at high school, this was your science teacher would often do this experiment, and there would be a wee pop of hydrogen gas at the end of it when he ignited it. So substances such as sodium, when we talk about sodium, we don't talk about sodium chloride that we put on our fish and chips, we're talking about sodium metal itself. Same as zinc and same as calcium carbide. Okay, so these are things that release gases that will ignite when introduced to an ignition source. Okay, and it's represented by that lovely blue pictogram, the blue diamond there. Okay, so they are our flammable solids. So the next class that we'll talk about now are our class 5 substances. So these are our oxidizing substances, Okay, so our 5.1.1 subclass of these oxidizing substances are either oxidizing liquids or solids. These are oxidizers that can cause or contribute to combustion of other materials. Okay, so a very common example of an oxidizing liquid is our hydrogen peroxide, of course. Then we do have things like sodium dichromate, calcium hypochlorite, and even nitric acid to some extent. They are represented by that particular pictogram there, that yellow diamond with the 5.1 beneath it. The next type of oxidizing substance, or the next subclass within this category, are our oxidizing gases. 5.1.2, gases that cause or contribute to combustion faster than air. So like things like pure oxygen, chlorine gas is put into this category also, and so is nitrous oxide. So on this slide, we also have a wee picture of what is known as the fire triangle. Okay, so those are the 3 main ingredients that are required to cause for fire to exist. And what these oxidizing substances do to this fire triangle is they increase that bottom part, the oxygen. So of course, when you get an increase of oxygen in this balance, that will of course increase the size of the flame or the intensity of the flame as well. So just be aware of that. The next slide we have across are our lovely organic peroxides, subclass 5.2. So organic peroxides cause or contribute to the combustion of themselves and other materials. And the reason why we say of themselves is because that organic side, okay, so when we mean organic, when we're talking about hazardous substances, we're not talking about organically grown vegetables or fruit, we are talking about things that contain fuel or things that contain a carbon atom. So with that, it means it actually contains its own source of fuel as well. So it contains oxygen and fuel. And as you can see there, with regards to our fire triangle, you can obviously see what could happen there if a fire was to exist that involved our organic peroxides. Very difficult substances to put out if they do catch on fire. Yeah, so they are quite hazardous. They are quite interesting substances. So the examples we have there are our methyl ethyl ketone peroxide, dibenzoyl peroxide also. Okay. So the next class we will talk about now are human toxicity classes. So let's just have a wee look at this. Oh, right. So our 6.1 is our acute toxicity. That's the subclass for acute toxicity, which are things that are poisonous, of course. So substances that have a short-term effect after exposure, such as nausea, dizziness, or insufficient dose. And it can also cause fatality, can cause death as well. So of course, we've got our things like our sodium cyanide. Those of you that are into the cloak and dagger type films, you'll find that spies will have a small amount of this encased in a false tooth somewhere. So just in case they get caught, they're able to proceed or be able to do what they have to with the sodium cyanide. So we all know that that is indeed acutely toxic. However, other substances that fall into this category are things like caffeine and sodium chloride. Quite interesting. Often I've had people ask me, is that a typo? Caffeine, we all have caffeine. It's in our coffee. Sodium chloride, I enjoy having a wee bit of salt on my popcorn, on my fish and chips. But indeed, yes, they are included as human toxic, acutely toxic substances. However, we can differentiate them when we look at the degree of hazard. So when we look at the degree of hazard, we'll be able to find out the differences between the sodium cyanide and the sodium chloride. Okay, so these acutely toxic substances are represented by those nasty looking pictograms here on the right hand side, our lovely skull and crossbones there with the wee six. And of course, this is also differentiated by that degree of hazard. So you're not going to go to the supermarket and buy your coffee and it will not have these skull and crossbones on it. Okay, so it is to do with the degree of hazard. The next two subclasses are our skin and eye irritants. They are represented by that particular pictogram there, the exclamation mark. And the reason why it is just an exclamation mark because these substances are not fatal. These substances do not damage tissue. However, they will sting if they come to contact with your skin and eyes. So for that reason, they are considered to be skin and eye irritants. Move on to the next slide. Okay. So these next lot of subclasses are known as chronic effects as well. So chronic toxicity is something that, the effects of the exposure to these types of substances may not make themselves obvious for years to come. So it may take a wee while for the illness or for the effect to take effect there. So our 6.5 subclass are our sensitizers. All of these substances are also represented by that particular pictogram there on the right hand side. So sensitizers are interesting. The 6.5, they can either be respiratory or dermal sensitizers. These are quite nasty substances. You can see there the examples we have: formaldehyde, isocyanates, glutaraldehyde, and iodine. So isocyanates in particular, they're respiratory sensitizers. And as I mentioned before, since they have a chronic effect, they might not affect you straight away. The isocyanates are regularly used in the automotive paint industry, and also to do with insulating materials or foaming type materials. So if you're exposed to these substances, you may not have a respiratory sensitization straight away. However, you might even get away with it for 10 years. However, after the 10th year and first day, you may develop some sort of a respiratory sensitization. And the sensitization is, it can take hold or take the form of, say, an asthmatic attack. If you're not an asthmatic in the first place, you may develop what's known as occupational asthma. And okay, so the issue with that is that, okay, you'll go home, you'll get better, you come back to work. What the problem is there is that after all of those years of you being exposed to it, if you come into contact with it now after being sensitized, it'll bring on an occupational asthmatic attack pretty much any time at very small doses. So that is what the sensitization is. It's your body saying, enough, we cannot take this type of exposure anymore. And the other type of sensitization, which is the dermal sensitization, skin sensitization. And it's pretty much similar. It may take a few years, however, eventually your skin will also say enough and you'll develop a type of dermatitis, allergic reaction, eczema, psoriasis from those particular substances that you are exposed to. The next subclass that we'll talk about are our 6.6 mutagens. Okay, and unfortunately, it's not like on the movies, where if you get bitten by a little spider, you get turned into Spider-Man. That's not the case, unfortunately. With mutagens, in real life, it causes very nasty effects. These are substances that can, as it states there, substances suspected or known to cause changes or mutations in DNA. So what it does, it affects your cells, right in the cell nucleus, where the DNA material is, and it interferes with the coding system within your DNA and forms a false code to be replicated that gets replicated and multiplies, and then mutated cells are formed, and basically that is how mutagens sort of start mutations of cells, which is often associated with the next subclass, which is 6.7 carcinogens, things that are suspected or known to increase the risk of cancer. Okay, so we've got some nasty substances there, the benzene, the potassium dichromate, the formaldehyde. All of these things are known or suspected to increase the risk of cancer. Often I've done courses where people say, oh, what, so you try and tell me my trike bath's going to give me cancer? Of course, we need to take into effect the stoichiometric effects there, where it's the randomness. Some people are susceptible to cancer, some people aren't. So it's just part of things that do cause cancer. So the next slide is 6.8 reproductive effects. Okay, so these are substances that can have effects on reproduction, fertility, things that can be passed on to an infant via breastfeeding. And also with these kind of things, they can also cause birth defects. So you've got ethylene oxide, carbon monoxide, benzene. Another nasty example of these of reproductive effects, 6.8 toxicity, is a thing known as thalidomide that was readily available in the 50s and 60s. It was a medication used for morning sickness. And unfortunately, because of the racemic mixture of the thalidomide, half of it, of course, it helped with the morning sickness, but of course it comes in that mixture. So the other half caused birth defects where the children would be born without arms or legs. Okay, so that is our 6.8 reproductive subclass. And then we have 6.9, which is the final subclass in the grouping of human toxicity. These are things that are target organ or have systemic effects. Okay, substances that have a short or long-term effect on specific organs, for example, liver or kidneys, or systems, so example, central nervous system there. And a good example of this, of course, is the old methylated spirits. It was an old wives' tale, well, I thought it was, that if you were to accidentally consume methylated spirits, it will make you go blind. But of course, this is indeed the case, due to the fact that it contains methanol. The old style methylated spirits, the methylated spirits that contains methanol, of course, will interfere with the optic nerve, and it'll stop or inhibit the function of that optic nerve. So any kind of images that you are witnessing through your eyes do not quite make that image, does not get converted to an image into your brain, so you're not actually able to see anything. So it affects the optic nerve, target organ systemic. So that's a systemic effect. So it's not just methanol and blindness, but it can, of course, lead to any kind of liver functions, kidney disorders, anything like that, and central nervous system. Another great example of a target organ and systemic effect. Actually, it has both effects. There's a nasty substance known as hydrofluoric acid. Of course, coupled with its corrosivity and its acute toxicity, the target organ and systemic effects are one that if you were to have skin exposure to hydrofluoric acid, you will not actually feel it burning due to the fact that it cuts off the signals from the nervous impulses, the potassium, the sodium gates that exist within the cells of the nerves. It stops them from functioning properly, and you cannot feel the sting, you cannot feel the burn from these acids until it's too late, until you actually see it burning on your skin. What it also does is that once it gets into the bloodstream, it disrupts the calcium levels within your bloodstream, and a large enough disruption of those levels can cause cardiac arrest. So with hydrofluoric acid, it's quite a nasty example of a 6.9, a target organ and systemic effect toxin. Okay, so as mentioned previously, there are no class 7s, and also you may have noticed that there is also no 6.2 substances, no 6.2 subclasses. They represent biohazards, they represent bacteria, they represent sewage, they represent medical waste, and of course nasty viruses out there. So the 6.2, and of course with 6.2 it's not managed under HSNO, so therefore not part of our classification, HSNO classification talk. So again, class 7, not radioactive materials, not managed under HSNO, so not part of our HSNO classification talk. So we're able to jump straight to class 8, corrosive substances. Okay, so these are substances that will destroy and damage other substances with which it comes into contact with. So what we need to remember with our corrosive substances, our class 8 substances, is that they do not just include acids, but also caustic substances are indeed corrosive as well. So we do have a wee table there, differences between acids and alkalines, and some substances there, or some things that give you an idea of what things are acidic and what things are alkaline. They are represented by those particular pictograms there. If you're wondering the difference between the red border and the other one, the one without the red border are the GHS pictograms, and the other ones there are our HSNO pictograms. This one here. So our corrosive substances, class 8. So things that are corrosive to metal are represented by the subclass 8.1. Okay, so as you can imagine there, you've got various substances: hydrochloric acid, mercury, oxalic acid. Things that cause burns and permanent damage to dermal tissue or to skin are things that are subclassed as 8.2 corrosive substances. And then finally, 8.3 are things that are corrosive to eyes, in other words, things that will cause burns and permanent damage, so damage to the ocular tissue. So that's the difference between the irritation, skin and eye irritation, to skin and eye corrosion or corrosivity. So when it is more severe, in other words, when it damages ocular and dermal tissue, it then becomes a class 8 substance, not just a 6.3 or 6.4 irritating substance. The next class here that we'll talk about is ecotoxic substances, things that cause damage to the environment. So subclass 9.1 are our aquatic ecotoxicity. So these are things that will harm animals and plants in an aquatic environment. So not just the water, but also any kind of algae, any fish, the plants, crustaceans, they all have ecotoxic effects and are represented by subclass 9.1. Subclass 9.2 is ecotoxic to things in the soil environment. So not necessarily the geology of the soil, but more so the microorganisms that live within that biome that allow things to grow, allow things to germinate. The ecotoxic 9.2 subclass there are things that will kill those microorganisms in the soil. 9.3 are things that are ecotoxic to terrestrial vertebrates. Living creatures with backbone, except for people. The reason why it doesn't include people is because we have our whole class to ourselves, known as class 6, being human toxicity. And then 9.4 are ecotoxic to terrestrial invertebrates, things without backbones, insects, worms, things like that. Okay, so those are the subclasses of our HSNO classification system. So the final part of the jigsaw puzzle here is our famous degree of hazard. So I'm not too sure if you remember to a previous slide where we started talking about acutely toxic substances, and we found that sodium cyanide was on the same line as sodium chloride and the caffeine and things. So it's this degree of hazard that differentiates that. Okay, so anything from A being, as you can imagine, A being the most hazardous all the way down. So just a heads up now as well, with this degree of hazard system, it's slightly different if we were to talk about explosive substances, okay? So the degree of hazard works slightly differently than all of the other hazardous substances from classes 2 to 9. So let's just have a look at this. Let's just have a look at some examples. So we talked about toxicity. Let's have a look at acutely toxic substance. So we'll just acute toxicity based on toxicity. So this is that degree of hazard. This is how it's differentiated. These are the lines in the sand that they have made to ensure that we understand the differences between a 6.1A, 6.1B, 6.1C, D and E substance, okay? So this is all based on oral toxicity. It is measured by a thing known as oral LD50 course, and we're familiar with how this works. It's basically during testing on animals or humans or whoever it is, when they've tested it on the subjects, where 50% of the population have ceased to exist or become expired. This is how we're able to gather our measure of LD50 or toxicity for particular substances. So if we check out 6.1A, example, sodium chloride, oral LD50 is equal to or less than 5 milligrams per kilogram body weight. If we look at that, we'll put that perspective. If we put that in perspective, just imagine someone who's, say, 100 kilograms. I always use 100 kilograms. Of course, it's easier to multiply by 100 than it is to multiply by 77 or 82 or something like that. So the person who's 100 kilograms, for this 100 kilogram person, they would require, or that if they were to ingest anything from around about 500 milligrams or less of the 6.1A substances, it can be fatal, or it's likely to be fatal unless they get to the hospital or get medical attention as soon as possible. So that is for a 100 kilogram person. Just imagine if you're only 50 kilograms, it'd be half that again. Okay, so when I say 500 milligrams, that's only a half a gram of these particular substances. The next on the list is the 6.1B oral toxicity. Okay, and the LD50 for them is 5 to 50 milligrams per kilogram of body weight. Okay, so this is interesting. So anything from a half a gram to a teaspoon for this 100 kilogram person can prove to be fatal. So for that reason, 6.1A and 6.1B substances require certified handlers. They are indeed fatal if they have doses of less than 5 grams for anyone that's 100 kilograms. Okay, so the next one down the line there, we have our 6.1C. Methanol actually falls into this category. So it's anywhere from a teaspoon all the way up to around about 30 mils or 30 grams of a particular hazardous or toxic substance. So that's quite nasty there. And then you go down to the next one there, 6.1D is our paracetamol, anywhere from 300 milligrams per kilogram up to 2,000 milligrams per kilogram of body weight. So paracetamol somewhere in the range of sort of 300 to 400 odd milligrams per kilogram. Okay, so it is over 300 milligrams per kilogram of body weight is the toxicity, which is not that much at all. That's small amounts. So it's very, very important that you're aware that you're only taking the required or suggested amount of paracetamol doses that they tell you on the box, and not to exceed that, because it is actually toxic, and there have been cases of people dying from paracetamol poisoning. So yeah, it's very important that you take heed to that. With the paracetamol as well, the toxicity is very similar to caffeine. So if you can remember to that slide beforehand, caffeine was considered to be acutely toxic. Of course it is. However, the doses of caffeine that you receive in your coffee, it's around about 32 milligrams per 100 mils. So per litre, it's 320 milligrams, okay? So for the caffeine to have a toxic effect on you, you'd have to consume quite a lot of it. Of course, there's many different factors that can change this. It can come down to the individual and how responsive they are to certain toxins. They may be more sensitive, so they might not need as much. But this is just from the information that's been provided to us through that minimum degree of hazard notice, and that is how they've drawn the line in the sand there. But the point I'm trying to make there is that with the paracetamol, they're giving you 500 milligram doses at a time. So that's why it's very important to be aware of how much paracetamol you are consuming within a 24-hour time frame. Okay, that's our 6.1D. Oral acutely toxic substances, and then finally our 6.1E. This is where we find our sodium chloride, the lovely salt that we put on our fish and chips. Okay, so if you're able to consume anywhere from 200 grams to half a kilo of salt all in one go, then that will be fatal. It is unlikely that that's going to happen. The human response has gag reflexes that will not allow you to consume that much salt. And just to put it in perspective again, there is a notable exclusion from this degree of hazard as set out by the minimum degree of hazard notice, and that is ethanol. We've all heard of ethanol poisoning, alcohol poisoning. However, ethanol does not make this list. It has an acute toxicity of greater than 5,000 milligrams per kilogram. Okay, so in other words, you need to consume more than 500 milliliters of the pure ethanol for it to have a toxic effect on you. So just be aware of that. And if we're going to take it that far, we might as well even talk about water. Water, if you're able to consume 9 litres all in one sitting, well, not one sitting, in one go, which is impossible, that is considered to be a toxic amount as well. Okay. If you have any questions about this, send it through on your Q&A panel there, and we'll try and answer as many as we can. And if we run out of time answering the questions, we can also send emails through. The next slide there is our degree of hazard with regards to flammability. Okay, so again, it's to do with that flash point and the boiling point. So the 3.1A substances, including our petrol, has a flash point of less than 23 degrees Celsius, and it boils at less than 35 degrees Celsius as well. For a fact, I think petrol's flash point's minus 40 degrees Celsius. So yeah, it is indeed quite flammable. The next degree of hazard is a 3.1B, and the only difference between those two degree of hazards, the 3.1A and 3.1B, is the fact that the boiling point of the 3.1B now is greater than 35 degrees Celsius. 3.1C, the flash point now is greater than 23 degrees Celsius, up to 60, and then finally our 3.1D, the flash point is greater than 60 degrees Celsius. So that includes diesel. Okay, so these substances that are around about 3.1D are generally considered to be more so combustible than flammable. Excellent. So that pretty much draws us to the conclusion of our little HSNO classification talk. We covered the HSNO classes, the subclasses, and those degree of hazards. Okay, so as mentioned earlier on, we get our information, or our guidelines are set by the EPA hazardous substance classification notice for those classifications, and also for hazardous substances, it is the hazardous substance minimum degree of hazard notice 2017. So yes, do leave your questions here, and you've been a marvellous audience, so thank you very much, and we will catch up at another time. Our next webinar, of course, is Friday morning. So if you haven't registered yet, get in there, fill out your registration. And the next talk will be to do with material safety data sheets and how to read through them, what could be a complicated matter, and we'll just simplify it a wee bit so we sort of understand. So hopefully we'll see you all on Friday morning. Thank you for coming. You've been a great audience, and we'll see you Friday morning.